So right here for the CircuitPython Parsec today, I want to talk about using Unicode characters, particularly Unicode boxes and blocks, in the REPL to help with visualizing things in your code. So this is an extension to some degree of last week where we looked at the ANSI escape codes to be able to do things like refresh the screen without just creating a stream of data, moving the cursor around, sending very specific color codes and inverse codes and things like that. So one of the things that I had originally done this for was to make a little visualizer, like a VU meter for myself. And one nice way to do that is with Unicode graphical characters. So if you look in my, I'm going to go ahead and resave. If you go ahead and look in my REPL down here right now, you can see I've got a bunch of interconnected circles being printed. I'm going to go and change one thing right here. I'm going to change this to a full block and print that. And you'll see I get this nice thick bar across here. This is actually 6 copies of the Unicode rectangle, one after another. And so the way I'm doing this is I'm creating a variable, just for convenience here, that is in quotes \u, which is what tells it we're going to be using a Unicode character, and then the Unicode number, in this case 2588, which is this rectangular block. Then in my main loop, I am using the ANSI escape codes to clear this screen and put the cursor right at the beginning of the line. I'm putting a blank space, and then I'm printing 6 of whatever the current block code is. So if I go ahead and make this a half-width version of that, which is Unicode 258C, and hit save, now you'll see I get this little 6 boxes that have a little space between them. And in fact, let's see if I can zoom this up a little bit bigger for you. My code is nice and short here today, so you can see those a little better. And then for myself as a little reference, I've printed some Unicode characters that I might want to try out and what their codes are and their names. So for example, we can make a little row of teeth. 258B is the white down pointing triangle. 258B. I think I got that wrong. It is 25B3. I misread that entirely. And I typed it wrong. 25B3. Here we go. Save. Oh, those are the upward-facing ones, and then what were the downward-facing ones? D. Hit save. And so there you can see I got a nice little set of graphics there that you can't really use just ASCII art for. These are a little more specific than that, specifically designed graphics. And you can look online if you go. There's a nice Wikipedia article that sums these up, all kinds of Unicode characters that you can use. And some sort of a chicken and the egg thing sometimes of like, well, if I don't have one of these to copy and paste, I can't really put it into my code. And where do you store these? So I like having these Unicode characters available as a way to use some different interesting graphics. Now, as a example of why I would go to all this effort, I'm going to go ahead and minimize the code here, and I will comment that out. And now I'll show you a little bit of example code where I'm going to use both Unicode characters for those little blocks and the ANSI escape codes so that I can refresh the screen from the top every loop that I go through. And I'm going to use that to graph the voltages on the 6 analog input pins on this Metro board right here. So I'll go ahead and save this, and I may need to expand the screen a little bit. And you can see here, I don't have anything plugged in, but if I put my finger under there and I'm essentially pseudo grounding these analog pins that are floating otherwise, you'll see I get a sort of little neat VU meter of those 6 readings, and I'm using the Unicode characters to populate that little graph there. All right, so that is Unicode, I think 3 or 4 of those little Unicode blocks, and then a fairly simple bit of code to determine where to draw those blocks based on voltage. The voltages are printed at the bottom too, so you can see I get these up to about 3.3 if I fully ground them. and they float around 0.1 or so, 0.2. So that is how you can use Unicode blocks in your CircuitPython code in the REPL, along with ANSI escape sequences to do some graphics inside of the serial output. And that is your CircuitPython Parsec.